Okay, so for quiz 10, number 1, set items are automatically stored in ascending order. Alarm bells should be going off in your head anytime you see order paired with sets. Sets are an unordered collection, so there's no concept of first or last, ascending or descending. That makes this question false. Okay, a dictionary can contain duplicate keys but not duplicate values. You should remember that the keys in a dictionary must be unique. In other words, the dictionary's keys must be a set of items. Okay, so that means a key cannot be a mutable thing. All keys must be immutable, and they must be unique. You can only have one key, one particular thing as a key. You can have two of the same value as a key. So duplicate keys are not allowed. Duplicate values, however, are perfectly fine. You can have multiple of the same value in a dictionary, and that will be just fine. That makes number 2 false. Dictionaries cannot contain multiple keys. So for number 3, we've got a dictionary. It's got 3 keys. Okay, the integer 1, the character 1, and the string 1. What is printed in each of these situations? So, first things first, we're going to print the length of this. So what is D at 0? Okay, D at 0, remember this is a dictionary. We're looking for the value 0. Does it exist in any of these keys? Nope. That means we have a key error. This key does not exist. Next up, we've got print D at key 1 at index 1. So in order to dissect this, we're going to first do the thing on the left, D at key 1. So what is that? Well, look at this. We've got that key, so the corresponding value is this list, 5, 4. So you can think of it like we're going to take this list and replace D at the character 1 with that value. So we're really looking up this index in this list. So what is it at index 1 in this list, 5, 4? That's just the number 4. So that's what gets printed. So for the next one, we have a d.get. So remember, .get works by trying to look up the first thing as a look up the value of this key in the dictionary D, and should it not exist, it's going to use this second argument as the default value. So if I can't find 1.1 as a key in the dictionary D, I'm going to print out 1. If I do find the key 1.1 as a key in the dictionary D, then I will print whatever the value at that particular key is. So remember, we only have 3 keys, 1, the string containing the digit 1, and the string ONE or 1. None of those 3 things are the floating point number 1.1. So we're going to print the default value that we're using as .get, or just the number 1. So for this last one, we are asked to look up this key in the dictionary D. So we'll see that yes, 9876, the tuple, appears as a value corresponding to the key with the integer 1. However, we are going to see that an error occurs here. The error itself is not because it's bad to look up exactly the tuple 9876. Remember that tuples are immutable. Keys in a dictionary must also be immutable. This is a valid lookup. It's okay to try to find a tuple as a key in a dictionary. It's not okay, though, if it doesn't exist. So this key doesn't exist. Nowhere in this sequence that we've given is there exactly a tuple 9876 that appears on the left-hand side of a colon. Right? None of these keys are equal to this tuple, and so we have a key error. We are unable to look up this key. We get an error. So for this next problem, I want a single line of code that will change the dictionary D to this exact dictionary. I can't reassign D or any of its items. You must modify the dictionary contents. That means there should be no more equal signs being written in this problem. So how do I make this dictionary equal to this one? Let's first find where the differences are. So at the key 2, that is over here. This value is 0, 1, 2, 3, the tuple, and its value is 0, 1, 2, 3, the tuple. So there's nothing to do about that particular key value pair. Let's check the next one. So there's the key with the digit 2 is a string. Oh look, there it is. Let's see if the values match. We've got the list 5, 6 and the list 4, 5, 6. So there's definitely something that has to get changed there. Let's remember that for later. Look up this last one, 2, 2, the values match, and so there's nothing to change there. So somehow we have to go from this to this. So I know for a fact I must first look up the value in this dictionary in order to be able to do something to it. How do I do that? Well, I take the dictionary D, I use my bracket notation to look up exactly this key. So whenever I say D with a pair of brackets and the digit 2, I'm actually referring to the value of this particular key. So if this happens to be a list, that means I can directly do things to this list, like append and extend and index and all these different things. So what will help me here in order to put a 4 at the beginning of this list? Well, that's where insert comes in. So I'm going to insert at position 0 the number 4 inside of this list found at this key in the dictionary. And that should be it. Number 5, what is printed by this code? So we've got a dictionary. D, it starts off as empty. That's neat. So we've got an empty dictionary. There is currently nothing inside of it. No key value pairs. For I in range 2 minus 2 minus 2. So let's figure out what this will do. How many times will this run? Well, it's going to start at the number 2. We're going to be counting down by 2. So from 2 we go to 0. Our ending point is minus 2. So if I were to go further, we'd see that we have to be including this ending point. That means that we're going to actually be stopping at 0. So the range that's generated here is exactly equivalent to this list, 2, 0. So the question here is, what happens in this loop? So this loop is going to run the first time. The value of I is going to be the first entry in this range, or 2. This line of code executes the first part of this loop, where we say D at 2 equals I. So this says, at the key 2, inside this dictionary D, set the value at that key equal to I. So we're going to come over here to our dictionary. We're going to add 2 as a key, and then we're going to put the value of I into this value. So look, the value of I is 2. So the key value pair, 2, 2:2, gets entered into this dictionary. Now the loop isn't over yet. So the loop says there's one more thing, right? So the value of I gets updated to be 0. Okay, so our next thing is we go to this dictionary at the key 2, and we update the value at this place to be the value of I. So we go to our dictionary at key 2, and we change the value. It used to be 2, now it's 0. So when I exit this loop, right, because there's no more numbers to be to work through in this range, we print D. What is D? It is exactly this dictionary, 2:0. So there's a couple ways to write number 6. I'll do the long way first, the short way second. The long way will be something like this. So let's write our find function. It takes a dictionary D and a second parameter V of some unknown type. So I'm just going to do D comma V here. What we're doing is checking to see if V is a value in this dictionary. We don't know what type it is, but that's okay. I don't need to know the type. All I need is really just the dictionary. So let's, in order to find if V exists, we want to loop over the dictionary and check if V is the value at this particular location. So if you remember, there are many different ways to loop over a dictionary. One way would just be for every key in the dictionary D, let's look up the corresponding value by going into this dictionary at this particular key and then check, hey, if this value that I got is equivalent to V, the value that gets entered into my function, then that means I should return true because I have found this item, this value in the dictionary. If I get to the point where this loop is over, I'm going to return false because this loop will have gone the entire over every single key in the dictionary and not found this exact value. So that means the key doesn't exist. We should return false. Now, the shorter way to do this is, if you remember, the dictionary has a couple different special methods that allow me to access exactly a list of keys, exactly a list of values, or exactly a list of items inside of this dictionary. What we're going to do is leverage the fact that that these are already built in to write a very, very short version of this function. I'm going to leverage d.values. What we're going to do is have the same signature, dv, and all I need is to check, hey, is this value v in this dictionary's values? And all I have to do is return the answer to this exact statement. So if I say no, r is equal to that, return r, just for the sake of space. And you could also write return this, v in d.values.